chemistry. Cheers. Dude, get out of the way.
Oh, okay.
This is the chemistry of alcohol, and I'm Brandon.
And I'm David Gonzales.
What is alcohol? In order to understand alcohol's effects of the body, it is helpful to understand the nature of alcohol as a chemical. So let's take a look. Here are several facts. Alcohol is a clear liquid at room temperature. Alcohol is less dense and evaporates at a lower temperature than water. This property allows it to be distilled by heating H2O and ethanol mixture. The ethanol evaporates first. Alcohol dissolves easily in water. Alcohol is flammable, so flammable that it can be used as a fuel.
The alcohol found in alcoholic beverages is ethyl alcohol, ethanol. The molecular structure of ethanol looks like this. In this structure, C is for carbon, H is for hydrogen, O is for oxygen, and the hyphens are the chemical bonds between the atoms. The OH group on the molecule is what gives it its specific chemical properties of an alcohol. For the remainder, when we say alcohol, we mean ethanol. You will not find pure alcohol in most drinks. Drinking pure alcohol can be deadly because it only takes a few ounces of pure alcohol to quickly raise the blood alcohol level in the danger zone.
How alcohol enters the body. Alcohol effects. Men versus women. When you compare men and women at the same height, weight, and build, men tend to have more muscle and less fat than women. Because muscle tissue has more water than fat tissue, a given dose amount of alcohol will be diluted more in the man than in the women. Therefore, the blood alcohol concentration resulting from that dose will be higher in a woman than in a man, and the woman will feel the effects of the dose of alcohol sooner than the man will. When a person drinks an alcoholic beverage, about 20% of the alcohol is absorbed in the stomach and about 80% is absorbed in the small intestine. How fast the alcohol is absorbed depends upon several things. The concentration of alcohol in the beverage, the greater the concentration, the faster the absorption. The type of drink. Carbonated beverages tend to speed up the absorption of alcohol. Whether the stomach is full or empty, food slows down alcohol absorption. After absorption, the alcohol enters the bloodstream and dissolves in the water of the blood. The blood carries the alcohol throughout the body. The alcohol from the blood then enters and dissolves in the water inside each tissue of the body, except fat tissues, as alcohol cannot dissolve in fat. Once inside the tissues, alcohol exerts its effects on the body. The observed effects depend directly on the blood alcohol concentration, BAC, which is related to the amount of alcohol consumed. The BAC can rise significantly within 20 minutes after having a drink.
Вдахнете глибоко і дуйте, доки не кажу. Айде. Айде, будь друг.
Idu pičku, magozema.
Mogu da pijem.
Ne zaduvaj me, ne vuče, veli.
Ne da vučeš, nego da ovako držiš i da duvaš.
How alcohol leaves the body. The breakdown of alcohol. The breakdown or oxidation of ethanol occurs in the liver. An enzyme in the liver called alcohol dehydrogenase converts the acetaldehyde in the presence of oxygen to acetic acid, the main component in vinegar. Once absorbed by the bloodstream, the alcohol leaves the body in 3 ways. The kidney eliminates about 5% of alcohol in the urine. The lungs exhale around 5% of alcohol, which can be detected by breathalyzer devices. The liver chemically breaks down the remainder of the alcohol into acetic acid. As a rule of thumb, an average person can eliminate 0.5 ounces or 15 milliliters of alcohol per hour. So it would take approximately 1 hour to eliminate the alcohol from a 12-ounce, 355 milliliter can of beer. The BAC increases when the body absorbs alcohol faster than it can eliminate it. So, because the body can only eliminate about 1 dose of alcohol per hour, drinking several drinks in an hour will increase your BAC much more than having 1 drink over a period of an hour or more.
The effects of alcohol. If you have seen someone who has had too much to drink, you've probably noticed that definite changes in that person's performance and behavior. The body responds to alcohol in stages, which corresponds to an increase in BAC. The first stage is euphoria. In euphoria, many things happen. One main one is attention span shortens.
What?
The second one is excitement. During the excitement phase, the vision becomes blurry, they lose balance easily, they become uncoordinated. The third state is confusion. They're confused, they become dizzy and may stagger. Sometimes people become highly emotional.
Dude, I got the next part. Let me do it. The effects of alcohol continue. The next step or phase is stupor. Stupor, our patient or a person will barely move at all. They'll barely be able to respond to you. They may vomit. They may lose consciousness. Our next step would be coma. They are unconscious. Their reflexes do not react. And our final step is death.
How the body responds to alcohol. Alcohol acts primarily on the nerve cells within the brain. Alcohol interferes with communication between nerve cells and other cells, suppressing the activities of excitatory nerve pathways and increasing the activities of inhibitory nerve pathways. Due to the interruption of the neurotransmitters, it slows down the body's sympathetic and parasympathetic nervous system, the SNS and PNS. Alcohol affects various centers in the brain, both higher and lower order. The centers are not equally affected by the same BAC. The higher order centers are more sensitive than the lower order centers. As the BAC increases, more and more centers of the brain are affected. The order in which alcohol affects the various brain centers is as follows. Number 1, the cerebral cortex. Number 2, the limbic system. Number 3, the cerebellum. Number 4, the hypothalamus and pituitary gland. And number 5, the medulla, or the brainstem.
Alcohol and serotonin. Alcohol can alter serotonin reuptake or affect brain monoamine oxidase, an important enzyme in the metabolism of serotonin. The problem is that alcohol is also an addicting drug, and its effects are short-lived. Long-term use of alcohol affects brain serotonin quite differently.
Alcohol, one of the most commonly used and abused drugs in the world, comes in a variety of forms and does one thing quickly and well. It changes the way you feel. But to what do we owe these feelings of release and freedom? How could the ingestion of one simple substance so drastically change not only your actions, but thoughts and perception? As alcohol enters the body and makes its way to your brain, it begins to interact with your neurons or brain cells. In our previous video on marijuana, which you can click here, we explain the actions of neurons and their chemical messengers called neurotransmitters. But there are two main types of neurotransmitters that these neurons use to communicate or send electrical signals. Excitatory neurons use glutamate while inhibitory neurons use GABA, the yin and yang if you will. Much like the zeros and ones of a computer, these two messengers have contrasting roles. Glutamate begins a wave of excitation, while GABA not only inhibits this flow, but helps to organize and differentiate the results in your brain. And just like a computer, these signals can be combined in enormous complexity to form actions and thoughts. So how does alcohol affect these two signals? Turns out it suppresses glutamate transmission and enhances GABA transmission, so you get less excitation and more inhibition. And because glutamate sites become less effective, information flow becomes slow and only the largest signals can make it through. This means you feel less, perceive less, notice less, and remember less. In conjunction, the increased GABA hushes the excessive background noise of activity, fine-tuning and clarifying your thoughts, but to an excessive degree. This is why you may have heard that alcohol is a depressant, but inhibition of your neurons is not the same as social inhibition. Instead, it simply cleans up and removes extraneous activity by removing less significant excitation. Without normal GABA transmission, the excessive excitatory action would resemble an epileptic seizure. There would be no clarity of thought. While drunk, your GABA channels are wide opened. Combined with the lack of glutamate, you begin to think very little, but with great clarity. It's what causes the momentous attitude of a drunk, often repeating the same idea or proclamation over and over, thinking clearly about almost nothing. Got a burning question you want answered? Ask it in the comments or on Facebook and Twitter, and subscribe for more weekly science videos.